Hey everybody, it's Mr. Carr again. Today we're going to be talking about 6.5 day 2 is the rest of our operations with radical expressions. So we did talk about before about how to multiply radicals, but we did not talk about it in this format. So here we're going to expand not by applying FOIL, but we're going to distribute. Okay, so we're going to distribute these two, then simplify our radicals and add our like terms after that. So when we do our distribution, remember we're taking 2 root 3 times both of these. So I can take 2 times 3 times the square root of 3. And then I'm going to subtract 2 times the square root of 3 times the square root of 3. I'm going to do the same thing here. We got 3, so a positive 3 times the square root of 5. And then this one right here is a positive 3. Whoops, this could be negative. So negative 3 times the square root of 5 times the square root of 3. Remember, when we do this, the only things that multiply together are if the numbers are both on the outside of the radical or both inside the radical. So in this scenario, I've got 2 times 3 is 6 square root of 3. Here I've got 2 times the square root of 3 times the square root of 3. Well, these are the same things multiplied together. So this is actually going to turn into 2 times 3. Okay, so that's then 3 times 3 is 9 times the square root of 5. And then over here, I can multiply these together when I put them under the same radical. So it'll be 3 times the square root of 15. Okay, there's not gonna be any more like terms after this, so I'm just gonna go ahead and multiply these together. I like to bring that out to the front, so negative 6 in the front, and then plus 6 square root of 3, plus 9 square root of 5, minus 3 times the square root of 15. Okay, and that's it. There's no other like terms. Double check just in case. Can you break that down? You can't. Everything else is prime. Okay, so you try that one on your own. Bottom line is we're multiplying just like two binomials, so we're distributing here. In this example, in the triangle shown with the height x, the ratio of the base of the height to the base is x over x root 3 plus x. We want to rationalize the denominator of this expression. Okay, so when we rationalize it, we're going to do what's called a conjugate pair, which is something we did back when we did our imaginary numbers. Okay, so in this scenario, to rationalize this, we have x root 3 plus x. The conjugate pair in this case is just the opposite sign again. So we're going to multiply by x root 3 minus x. Okay, x root 3 minus x. We do the same thing to both the numerator and the denominator. So here, if I distribute the x to both of those, I'm going to end up with x squared root 3 minus x squared. Okay, underneath, we'll have x root 3 times x root 3. So that's going to be x squared, but then root 3 times root 3 is just going to give me 3. So I'm going to have 3x squared there. Okay, and then x root 3 times a negative x is a negative x squared root 3. Positive x times x root 3 is going to give me a positive x squared root 3. And again, this is why we do the conjugate pair. These are opposites, so they're going to cancel each other out. But my last part is x times a negative x, so that's going to be a minus x squared. Okay, so from there, I'm going to just start seeing what I can combine. I'm looking ahead. I'm going to go ahead and do this. I'm going to factor out an x squared out of both of these because it's common. And it's going to be x squared times root 3 minus 1. My denominator is now going to be 3x squared minus x squared is just 2x squared. Notice what happened there when I factor out the x squared. I have common factors. I can take x squared divided by x squared. So now I have just the square root of 3 minus 1 all over 2. I guess I don't really need the parentheses here. Okay, and that's just one combined fraction. You can separate them. And sometimes we like to put our real number or the rational number in front lots of times, but I can basically separate it as negative 1/2 plus root 3 over 2. So that's what this original one combined down to. Okay, so that's again, that conjugate pair is what gets rid of the radical in the denominator. All right, this is the same exact thing. So we're going to skip that and go on to one more example like that. Okay, again, using the conjugate to rationalize the denominator. Okay, so to rationalize when a sum is in the denominator, multiply the denominator and then worry about the conjugate of the denominator. So this one is going to be multiplied by root 2 plus 3. Root 2 plus 3. Okay, so in my numerator, I've got 4 times the radical 2, 4 times 3. So I got 4 radical 2, 4 times 3 is 12. Square root of 2 times the square root of 2 is just going to become a 2. And then square root of 2 times 3 is 3 square root of 2. My denominator is square root of 2 times square root of 2 is a positive 2. And then positive 3 root 2. Then negative 3 root 2. And then negative 3 times a positive 3 is a negative 9. From there, again, these two cancel out. Combine my like terms, my numerator and my denominator. So I got 12 plus 2 is 14. 4 radical 2 and 3 radical 2 go together as 7 radical 2. And then 2 minus 9 is a negative 7. Double check these. So 14, 7, and 7 are all divisible by 7. So I'm going to go ahead and do that. If I divide everything by 7, and technically negative 7, I can do this here. This will turn into 14 divided by negative 7 is a negative 2 minus root 2. So divide by 7 is 1, divide by 7 is 1, divide by 7 is 2. Okay, and that becomes negative 2 minus root 2 there. And that's it. So we're just dealing with basically these two ideas. How do we distribute with our radicals? Okay, and also when we do rationalizing with something like this, we have to use our conjugate pairs. All right, that's it for today. Take care, everybody.